Hello and welcome to a demo of DFMPro for ProEngineer. DFMPro is a product from Geometric to get your designs right the first time. It helps in upstream manufacturability analysis validation, saves on design to manufacturing iterations, and reduces rework. Let's now look at DFMPro in action on a few prismatic milling, turning, and sheet metal models inside ProEngineer. Let's launch DFMPro. Since this part is going to be primarily manufactured using drilling prismatic milling operations, we select part type as prismatic mill. Let's select run and allow DFMPro to proceed. DFMPro uses feature recognition technology to identify the manufacturing features on this model. Using the manufacturing feature information, DFM checks are applied on this model. Based on the success or failure of the checks, corresponding information is shown to the user. We can see that currently DFMPro is recognizing the features and now the checks are being applied. Nine out of 34 rules have failed, 3 out of 34 rules have passed, and there are certain not applicable rules which are sheet metal rules or other rules which were not executed on this model. Let's look at the deep holes rule. We can see that when we select the instance, it is highlighted in the graphics area, and correspondingly a message is shown in the dashboard area. Which tells us that the depth to diameter ratio is 4.3818, whereas it is recommended to be below 4. We can browse the remaining instances of this rule failure. Other rule failures include fat bottom holes, sharp internal corners, fillets on top edges, pockets with bottom chamfers, and so on. For every rule, the same kind of behavior is exhibited. We can browse each and every instance, see the graphics area for the corresponding features, get the detailed information of the rule in the dashboard area. Additionally, we can also right click on an instance, select help to get detailed information from the DFMPro help document. DFMPro help document will provide the reasoning behind the rule and how the rule can be applied. One can group the rules according to criticality category, and one can filter the rules according to criticality. Let's see some examples. Having this facility allows the user to concentrate on a few rules, correct the errors, and then move on to other rules. The input to DFMPro execution is a rule file which contains the list of rules to be executed and their parameters. In this execution, the rule file was ozrules.dfm. The user can change the rule file to be executed by browsing, or he can edit the parameters in this rule file itself by clicking edit. Let's edit this rule file by clicking the edit button. This launches DFMPro Rule Manager. DFMPro Rule Manager shows us the selected rule file, all the rules which were selected for execution, and the rules which were not selected. For every rule, there is an associated category, criticality, and a module. Let's try to configure one particular rule and see its effect on DFMPro. Let's select the deep holes rule and configure it. Let's change the hole depth to diameter ratio from 4 to 10. Let's save the rule file and go back to ProEngineer to check the results. Let's rerun DFMPro. DFMPro will now reapply the changed parameters on this model and show us the results accordingly. All the rules are re-verified according to the changed rule file. Now we can see that the deep holes rule is no longer listed in the rules failed list. This is because of the changed parameter. Now it has moved into the past rule list. So that's how DFMPro makes use of the rule file dynamically inside ProEngineer. On the other hand, a more realistic scenario would be a user who finds an execution of DFMPro resulting in a rule violation, changes the model at runtime, corrects the error, and then reruns DFMPro to ensure that the rule violation gets corrected. Let's now look at a sheet metal model from DFMPro standpoint. For this model, we will select part type as sheet metal and select run. For sheet metal models, DFMPro needs a reference face, which is the fixed face for the sheet metal model. Users can go ahead with the selection made by DFMPro or apply their own choice. Even in case of sheet metal rules, feature recognition technology comes into play to recognize the corresponding sheet metal features on the model. Based on the feature information, the corresponding DFM checks are applied and the results are shown to the user. The part is now processed and we have the following rule failures. Let's browse the rule failures for sheet metal. The first rule failure is related to minimum hole diameter. This is the message displayed, which will allow the user to know the parameters which are affected due to this rule failure. Since the instance is very small, it is not readily highlighted in the graphics area. To solve this problem, just right click on the instance and say zoom to selection. DFMPro zooms onto the failure instance to identify and locate it correctly. To zoom out, one can select zoom to fit. To get more information on the sheet metal rule, select help. Similarly, you can browse other rule failures as well. Even in the case of sheet metal, the rule manager details remain the same. One can edit parameters of sheet metal rules inside the rule manager as well. This video gives a brief introduction into DFMPro for ProEngineer. Please watch the next video to get an idea about DFMPro customization.